This is a collaboration between Hal Christensen and myself, and we've actually broken this up into two presentations. And I'll point you to where the next one is, where Hal will give you some very practical examples. But the question I was trying to answer is, how should educators and workplace learning and performance designers regard, frame, and employ generative AI or AI in general for maximum learning and performance? Performance support has been around for quite a while. And so what we're going to do, because people have different backgrounds, is the presentation flow goes from a review to a practicum to conclusions. And what we're going to review first is performance support and then artificial intelligence. I'll say over and over again that what I state is around framing how a designer regards this and how to move forward, because there's a lot of questions about that now and a lot of misunderstanding about what both of these things are. And once we get through that, then I'll be doing a performance or task analysis on a real project, and then doing a simulation, extending it to AI to see task analysis, taxonomy for learning and performance. And then we'll look at performance support and AI fused together very tightly and what some of the issues are going forward. You don't have to read these things here. This is primarily for people who will look at these slides later. And we're going to return to that key question when I get to the end, hopefully right at 45 minutes. We'll start with a performance support overview. This all came from a wonderful woman named Gloria Geary, articulated back in 1989. Her response to computer systems that were stovepiped, poor usability, green screen, training was done far in advance of releases. Training was focused on the complexity of the tool rather than the work to be done. There was no in-context support. So if you look at this cascading thing here, if we're, I guess, around 1960s or so, past the punch card era, perhaps, we're on a line printer, with paper. There weren't even CRTs or screens. Then we had assembly language and machine language and green screens and stuff like that. There's only a very few people who could actually manage and handle computing. There was no such thing as end user computing at the time. That evolved to green screens against the mainframe, text-based, and that's where Gloria comes into the picture as a trainer at Aetna Life and Casualty, responsible for training people on some of the most god-awful systems that you've ever seen in your life that look kind of like this picture here. And then, Xerox PARC happened, all of that sort of thing. And many of the things that Gloria was talking about were manifested in usability engineering and the graphical user interface. And things started to get a little easier, but not meeting her vision. And now in around 2023, we have AI entering the picture, allegedly giving us a little bit more usability. And then as we move forward, we're talking about, agentic AI or autonomous agents. And you notice that the little icon there, the guy's not even touching the keyboard. But this is kind of a cascading of what Gloria was concerned about. When she wrote her book and that was published in 1991, these were the 19 attributes and behaviors of a performance-centered system, of EPSS, as she called it, Electronic Performance Support System. I'm not going to go through this. I don't expect you to read all of these, but basically they fall into three main categories. That performance support systems or performance center systems are contextual, that it knows your workflow, it knows where you are, it allows you to not have to leave the workflow to get your work done. It's human-centric. It has all the human factors and usability that is required, all the human preferences. And also for maximum performance and learning, intrinsic, meaning that if you're taking tasks from the work to be done and you are trying to reduce the complexity to them, it needs to be part of your workflow directly, not something layered on top of it or whatever. And I'll explain a little bit more about what that means in a few minutes. But think about these three things: contextual, human-centric, and intrinsic. I'm going to start out because I know there are a lot of attendees at the conference in higher education. And in performance support has found its way. Well, it was always there in early learning because in early learning, early childhood, there is no teaching. It's all learning by doing. It's hands-on experience. Adults are facilitator. In higher education, we realized that people need more personalization and where they are, individual assistance, concern about metacognition and knowledge management. And what has really evolved to the present day is a lot of project-based learning in the classroom that mimics or simulates or even does actual work that's done. And if you look at this next slide here, the things that are highlighted, these bullet points here came out of real studies. And if you notice the language here, these words are all the words that were in Gloria Gary's original attributes and behaviors. So it absolutely has found its way into education as a viable thing as technology has become more ubiquitous. Now, I'm going to play a video here to show you an example of kind of what Gloria had envisioned as a performance support tool that kind of sits on top of an application that may be difficult to use.
Your enterprise isn't keeping up with modern software and technology, causing employee productivity to drop. Here's why. Currently, your employees spend countless hours onboarding onto new software, only for them to forget and be obliged to retrain. With WalkMe's guidance, your employees are guided through any complex process with intuitive on-screen walkthroughs. At the moment, your employees are overwhelmed, using dozens of applications and software, causing their productivity to plummet. WalkMe automates complex processes and cross-application tasks with a single click. Your employees are disengaged from their software. They are unaware of the scope of the software's features, leading key functions to be underutilized. WalkMe's engagement targets and proactively prompts employees at the moment of need, using AI and contextual awareness. Lastly, you are lacking visibility. Right now, it's hard to know where your employees are struggling and how they're using their software. WalkMe's Insights provides analytics on software usage, allowing you to make data-driven decisions to accurately address inefficiencies and drive digital change. So, how can your enterprise keep up and achieve digital fluency? WalkMe's digital adoption platform is the ultimate answer to keeping up with technology.
This type of solution is extrinsic. It's not intrinsic. It's kind of tacked onto the application to try to help somebody move through. It does provide support and insight, but it does generate a lot of technical debt. And that's one of the reasons why I say extrinsic is not necessarily optimal. Intrinsic. In other words, why don't we just make the system work in a more human-centered way instead of having to add something to it to allow people to be able to perform? Performance support has evolved to performance-centered design. And here's a perfect example of a performance support system that is outside of technology. The author is Atul Gawande. In his book, A Checklist Manifesto, he's a surgeon. You may know who he is, but there is a surgical safety checklist with the World Health Organization. And all of this has reduced mortality rates and accidents in hospitals just by having checklists in the context that are contextual, human-centered, and intrinsic. If you've ever had an operation yourself, have you noticed that the anesthesiologist and the nurses and the doctor all come in and they actually write on the limb or whatever that's going to be operated on, and that's an element in the checklist. And look at the operating theater here. It's really remarkable how much technology is in there. And the old model of the surgeon essentially be the arbiter and the leader goes away with these checklists. Agency is distributed among the entire team. People are empowered to do certain things, and the coordination of all of this technology via a simple checklist is what keeps people safe and reduces the mortality rate. This approach was derived by Atul Gawande by observing skyscraper construction and the fact that you have so many different trades and how does it all get done without people stepping on one another. So that's performance center design. That's really my overview: computer-based, inline support, and then workflow, human-centric, and all of that. Now we're going to look at an overview of AI, and once again, from the perspective of how should I view this thing? Because there's a lot of misunderstanding and confusion about it. First of all, classical computing is deterministic, where you have an input and you get a predictable output. That's not what machine learning is. And I'm going to keep putting quotes around things like learning and intelligence because we're using the same terms for machines as we do for humans now. And I think that's a mistake. So, what happens with machine learning is you kind of train the algorithms and it learns patterns and then it provides not one output, but multiple outputs, not always expected. And for the same prompt, you can get different outputs if you ever play around with ChatGPT. The mathematics behind it is all about resolving ambiguity and trying to get to a crisp answer. And as we know, it's not always successful. This is a stochastic process, random in a sense, rather than deterministic. So we got to keep that in mind here. This is for advanced materials discovery. AlphaFold and AlphaFold 3 is about protein folding. And this is a modern AI system that earned Sir Demis Hassabis his Nobel Prize last year. And all of these things, GraphCast is for weather forecasting, DeepMind's genome is materials discovery, co-scientist is actually a way to simulate the laboratory. And what we're going to see is there's a cognitive shift going on. So it's not all about just the multimodal AI tools, but there's a lot more to what goes on with AI, from machine learning all through these different phases to the foundation models and everything that happens around them these days to make it more and more accurate is something that we should keep in mind. It's more than just a chatbot. And what happens, everybody's probably experienced this because in my consulting work, universities and businesses have come to me and say, my employer, my students, the AI monster is lurking around and sucking the intelligence right out of my group. What do we do? What do we do? Cheating and all of that sort of thing. What I want to do in this overview is to put some of that to rest. The influence of what you're seeing from day to day to day in the news and social media is primarily coming from the people who create the thing. Entrepreneurs, AI researchers, engineers, about 50%. This is a summary of about 6 different studies. You're hearing it from the people who are, nothing wrong with it, but making money off of this and who have a perspective on this is maybe more than it actually is. And the rest of these disciplines and domains, including educators and workplace learning professionals, have very little agency in this. Maybe a little bit more from cognitive neuroscience. That is the problem. And so we need to put that in perspective as designers. You've probably seen this curve because it's been socialized so much over the years now that we're heading for this dreaded inflection point, or sometimes called the singularity, where the machine intelligence is going to take over human intelligence. If you look at this slide here, watch it carefully, watch the shading. This is what it's implying. The human being is fading away and the machine is coming to the fore and it's going to take over. As a designer, throw that out of your head for right now because it conflates computing with intelligence, and there are problems with that. So rather than me give you my opinion, we're going to play 2 short videos. Roger Penrose, who is a Nobel laureate from 2020 in physics. He's a mathematician and mathematical physicist for his work on black holes, and Sir Demis Hassabis, who won his Nobel Prize for chemistry. He's a PhD in neuroscience and all sorts of things. He's also the CEO of Google DeepMind. He is the one who created AlphaGo Zero, where machines exceeded the performance of the best Go masters. The first video is Roger
What does the
Penrose.
proof mean? Well, usually it would mean you have your set of axioms and rules of procedure, and if you use them correctly and you derive this result from those axioms and rules of procedure, then you've got a proof. Now, what did Gödel do? But what he showed was that you could make a statement which in effect said, I am not provable by those rules. Okay, well, you can say, well, maybe it's false. But if it's false, then it is provable by the rules, and therefore it has to be true. It has to be true, but it's not provable by the rules. Now, this is very strange. You've got something which is true. You know it's true. How do you know it's true? Not by using those rules, because it's not provable by those rules. You know it's true because you understand why the rules only give you truths. It's your understanding of why the rules work gives you more than using the rules. What does understanding what the rules mean? Well, what is understanding? Well, it's something that involves consciousness. You see, it's a sort of, in the ordinary use of language, you say, an entity, does it understand something or not? Well, it rather implies, by the use of the word understanding, that it's at least aware of what it's trying to do. Can something understand something without even being aware of it? Well, not in ordinary usage. I mean, people might quibble about that. But the ordinary usage of the term understanding means at least it's aware of what it's thinking about or doing or something. Awareness, consciousness. So it does seem to imply that this is something to do with consciousness. And I believe whatever's going on in our heads must be in accordance with the laws of physics. So there's whatever those laws are, they have to be something, well, could be something you could put on a computer. Well, then they would be computable, and then you would be back in the trouble with the Gödel thing. And it seems to me it's got to be something in the physical laws which is acting in accordance with the laws of physics, but is not really something computable.
So that was Roger Penrose. And he's saying that consciousness and hence intelligence ultimately is not computable. Now think about that, and let's look at the next video with Sir Demis Hassabis.
So, Turing and Alonzo Church and many others also affiliated here, they came up with these ideas of Turing machines, the Church thesis, all of these things that are important about what computation is, foundations of computer science, and what is possible to compute. And of course, Turing famously invented the Turing machines, and he showed that they could compute anything that was computable, and therefore anything that was could mimic a Turing machine or approximate a Turing machine was also Turing powerful. And I think what we've shown in the last 15, 20 years as a field, and also through the work we've done, is that classical methods and running on classical computers can go a lot further than perhaps we previously thought. And do things like beat the world champion at Go, or fold, every protein known to science within a year. And so these are kind of pretty amazing things that would have surprised very, very smart people. I remember I'm struck with, I've had quite a few conversations with people like Roger Penrose about this, and he told me he was surprised by AlphaGo as a result, right? He would not have predicted that we could create systems that could beat the best humans at Go.
Classical systems.
Yeah, classical systems.
Yeah.
Maybe you need a quantum system or something like that. One has to really think through, like, when you step back again, like, what does these systems mean?
In your Nobel lecture, you proposed a conjecture yourself. I think we could have it up here.
Yeah.
Any pattern that can be generated or found in nature can be efficiently discovered and modeled by a classical learning algorithm, which grows out of what you were just saying. So what's prompted you to think about this particular conjecture, and what are its potential implications?
Yeah, I would say it's still in the formative stage. This is an early version of it. It may change, but it's my first sort of I guess attempt at trying to categorize what these class of systems are able to do.
What you just heard there says that intelligence, awareness, and all of those things that are so critical to human learning are not computable. So cognitive offloading is really not something to fear. Classical computability does produce surprising performance, but it's not intelligence. Awareness, intelligence, and learning remain outside the scope of classic computability, even though you can push it very far. Educators and learning and performance designers still have to address human learning and expand cognition and intelligence. You can't offload consciousness to computation. And that's, I think, a good lesson. I don't want to get into some of the more existential implications here, but the fact of the matter is that performance support, if it's a way for technology to take over certain tasks reliably to bolster human cognition and intelligence, then it's a perfect framework in which to place AI, generative AI, and other types of AI. So let's look at a realistic example. Some time back in my consulting days, we did a project at IBM where there were 400 tasks that needed to be trained or supported, and we're trying to figure out which one. It's a classic performance analysis. What we came up with was to rate the tasks by difficulty of learning, frequency, probability of failure, and consequences of failure. After all, the more difficult and the more consequential are the things you would normally train on or provide performance support. You notice that it forms a normal distribution. What we did was perform a number of simulations where many of the tasks were offloaded to AI. And what happened to the distribution is this. It flattened, the mean shifted to the left, it widened, and bottom line, without going through all of the rest statistics, is what had been 46% of tasks that could be embedded within the job as performance support grew to 70% of the tasks. So it still kind of sounds like cognitive offloading, perhaps, but that's not the whole story. Here's in a scientific area where I have a bunch of competencies. When the AI takes over, you have an additional set of competencies for human beings around data literacy and management, AI and machine learning fundamentals, a human AI collaboration, computational coding skills. A lot of times when the AI gives you a solution to something, it tells you something, even if it's in like ChatGPT, it's generating code that is giving you that answer. And if you don't have the competencies to evaluate that code, then we're liable to be fooled by hallucinations. There's a whole additional number of skills that arrive. It's almost like a game of whack-a-mole. The traditional competencies get lower while these new competencies that we have to emphasize go up. That implies different ways in which to organize our curricula and different ways in which to formulate the work to be done when we do an inline performance support system. The model that I think is important for us is to look at cognition as being distributed, because yes, we are offloading tasks onto AI, and that is one of many cognitive artifacts. What we need to think about is that here's a concrete example of physical artifacts. Suppose you were invited to dinner, and this is what you encountered when you went to sit down. Would you be very smart or intelligent about eating dinner if you encountered this? There'd be a lot more things you would have to do. There's complexity in a task to unravel all of this stuff and all. But no, what we do is we show up and there's a place setting. The artifacts are the dishes there and the seats. And when we sit down, the implements are where our hands are, all of that sort of thing. So the arrangement of those artifacts make us smart. I'm channeling Donald Norman here. And so what Glory believed in distributed cognition, but how do we move from physical artifacts to virtual artifacts? How do we get our arms around all of that? And that's the evolution of usability and some of the things you heard in the keynote this morning. So how do we fuse all of that? And you still do your task analysis. You still determine what tasks can be offloaded as performance support, and you figure out what needs to be trained, what doesn't need to be trained. But there, again, there's that new set of competencies. One of the most important things to realize about AI is the attribute disintermediation. If you look at these images, the one on the left here is machine language. The next one is assembly language. The next one is an early version of graphical user interface and end user computing. And the last one there is a dashboard that has visual display of quantitative information and other things like that. In each one of those iterations, it's democratized. More people are able to take advantage of the technology, and the number of translations with smart people or whatever gets reduced. Our whole goal is disintermediation after all. What we want, if we're dealing with the technology, we want to be able to communicate with it in a reliable way. We need to understand how and why we do that. I'm going to do another demo here, and this is an example of a performance support system to some degree as an autonomous agent. The guy that's not touching the keyboard is talking in plain language, and he's saying, create an interactive course on momentum theory. He is a middle school teacher, and he wants a job-related or a hands-on type of performance support system for his students on momentum theorem. And what you see is what it's doing explicitly for you on the left and what it's actually doing behind the scenes on the right. It's making checklists on how to proceed. It's writing code. It's going out to the web. It's finding things. All of that is happening in this very, very short period of time. And in a moment, what we'll see the outcome. And here's another video clip of what happens. We're starting out actually looking at basic collisions. You see where it says momentum's conserved. I can manipulate the mass of the balls and the velocity of them. As this proceeds, it goes from basic collisions to elastic collisions. It really is a very rich environment for somebody to be immersed in and to get a visceral understanding. A lot of learning can take place here. And if anybody here was not amazed by that, I would be very surprised. However, look at this carefully. It created a lot of good functionality, and there's some implication of workflow here, but it's not really all that explicit. The relationship between this and this and this and this, it's a lot of stuff on one screen. So what the AI gave me here, what the autonomous agent gave me, is not optimal. It's not necessarily completely human-centered. It's not completely usable. And we need to have the skills to interrogate that code. It's all the critical thinking stuff. So once again, as Penrose says, that awareness and the reasons why it works and how we regard it is not computable. It's another task that the AI can do, but it's not the whole story. You don't give AI a prompt and then completely accept what it gives you, because on the right side, that slide before, of all of those additional competencies, that's what we have to focus on, and that's what we are responsible for as designers. If you go back to that issue of the inflection point, we are moving to where the performance in more and more domains is becoming more and more remarkable, but there's a limit in classical computing to where that's going to take us. Hassabis said we can keep pushing it, but don't forget, he's a Nobel laureate, but he's also the CEO of a company. And remember that pie chart on the perspective. Believe me, I've been an entrepreneur myself, and I've developed a ton of performance support systems, kind of like WalkMe. You tacitly get pulled into this whole mindset that the marketing message gets all tangled up with the technical message. So We need to understand, first of all, the AI characteristics and landscape is going to change. Quantum computing is here. Instead of ones and zeros, they're qubits. They can occupy multiple states. You can see lots of examples where things that would take centuries for a classical computer to complete, the quantum computers are doing it in minutes or seconds. And we're making great strides with that. It's not in production as we would like it, but when it gets there, it's going to change the landscape of AI. It's going to look even more like we're closer to a singularity. And you have to keep these things in mind because those competencies, those tasks that it can do are more, and your human competencies need to increase. And so the whole nature of training, performance, and workplace is going to change. Another form of computing that I think we should be aware of is biological. They're using stem cells to create neural networks and connect them to artificial neural nets. And the footprint around what you can do with that kind of computing is very different. And then our movement from electrons in computing, which is what we do today, to photons, which is part of quantum, but this is an intermediate stage. So I would encourage designers who are using AI is please do not ignore what's going on around you, which things are changing very quickly. And that set of competencies in humans that you need to support is going to go up probably exponentially as the quote cognitive offloading happens. So you have a huge responsibility. The performance support is a great platform for this because it is all task oriented and about the work to be done. We also have to consider just very briefly the total cost of using AI. The human brain consumes about 20 watts of energy per day, regardless of the task or activity. AI training takes megawatts and machine inference is less, but it serves up billions. And there's a tremendous human labor cost in all of the tagging and all of the preparation for content that goes into machine learning. You've probably seen on the news all the concerns about data centers restarting one of the 3 Mile Island nuclear plants. There's a project underway right now where Microsoft has gotten involved because they need more electricity. And that's kind of a scary thing. One of the lessons here for designers is use this judiciously. I mean, don't try to open every design a peanut with an AI sledgehammer. Sometimes 3x5 file cards are highly underrated. I'm a big fan of Ethan Mollick. You can find him and his book on co-intelligence. And I think every designer should embrace this. Always invite AI to the table. Don't ignore it. Don't say, I'm worried about cheating or anything like that. Because I explained before, Roger Penrose, the key elements of learning are not computable and are outside the scope. So always invite it to the table to see what it can do. Do not take yourself out of the loop. And that translates to those additional competencies that we have a responsibility to address when we include AI. You need to treat the AI like a person, but tell it what kind of person to be. That's all about giving it context. If you want an answer to a medical question, or if the workflow involves that, then tell it what kind of surgeon you are. If you tell it you're an orthopedic surgeon, and you don't ask a neurosurgeon what the pain is about, you may get two different answers. And that's all content that is in the large models. So you need to be very specific in how much ambiguity you're creating by the prompt. That's what prompt engineering is about. It's about trying to identify the points of failure of the AI and not letting it fall through. And we call them hallucinations. We say it tries to give you the right answer. All of that is anthropomorphizing the thing. The point is that it's not conscious. It can't evaluate those rules. So you have to be very specific. Prompt engineering is nothing more than a form of extrinsic performance support. And I hope at some point that goes away and we can just collaborate with it in that disintermediated way. Because it changes so quickly, assume that the AI is the worst AI you will ever use. And the advances in computing are extremely important to that. So, what's our conclusion here? Remember the original question was how should educators and workplace learning designers regard, frame, and employ generative AI for maximum learning and performance? Integrate it tightly into real world tasks because what you're doing is offloading certain tasks and to try to make things easy. And if you don't frame it that way, you're liable to create more problems. You move from learning in advance to learning by doing. In other words, as designers, we need to adopt this notion of distributed cognition and that one of the artifacts is AI. Continually adapt competency models to embrace capabilities of AI and those of human scrutiny, arbitration. In other words, the critical thinking is that new set of competencies that we need to address in much more detail with much more diligence. Embrace a future in which humans and AI partner seamlessly to enhance performance, increase cognition, and expand human intelligence. What I always say is that as a cognitive artifact, the AI is not intelligent. It increases our cognition and hence enhances our intelligence. And do not open every ELMP peanut with an AI sledgehammer. And I always add this one, which is enjoy the ride. In your packet, there's all of the papers that are being published, and mine and Hal's paper with a lot more detail than I had time to go through here. And at the end of the paper, there's actually a primer for the LMP professionals, and there's 10 items that it covers and should be something that at least at the beginning help guide us toward this performance-centered approach. Dialogic methods, project-based learning, all of that with AI is really, really exciting. We can dispense with the fears. So I will encourage you as I open this up to questions to go to Presidential Room 1 after this. Hal is in the room and he's doing the other half of the conversation. If what I've been saying is a bit more cerebral and foundational and you're happy with, go to Hal's session because he's going to give you the real practical end of all of this with some more of the history of performance support. I'm certainly going to go listen to the session. So I can open it up now to questions and answers.
So thank you very, very much for the very impressive presentation. And any questions from the audience?